polar form of a complex number. So if our complex number, again, is z is equal to a plus bi, we know that r is the modulus of z, and that's equal to the square root of a square plus b square, and theta is the arctangent of b over a. So if you know the rectangular form of a complex number, you can always write that number as a polar point, and furthermore, we could write in polar form, we would say z is equal to r times quantity cosine of theta plus I times the sine of theta. And that would be the polar form of a complex number. Because if we remember from our right triangle trigonometry, B and A, we would have the cosine of theta is A over R, and the sine of theta is B over R. And so then solving each of those for A and B, we would come up with A is R times the cosine of theta, and B is R times the sine of theta. So that complex number Z as A plus BI can be replaced with saying that complex number is R times the cosine of theta plus B, which is R times the sine of theta times an I. And then when you factor out the R, you have that polar form of complex number, R times quantity cosine theta plus I sine theta. So let's write the number 3 plus 4i in polar form. Well, again, it starts by finding R is the square root of a square plus b square. So R is equal to the square root of 9 plus 16, which simplifies as R is the square root of 25, or R is equal to 5. So there's our directed distance, our modulus of that complex number Z. Now the angle theta is the arctangent of B over A. That tells us theta is the arctangent of 4/3. Arctangent of 4/3, this number here is 3 plus 4i. 4, and this side is 3, and this side is 5. What angle theta does that correspond to? And that angle would correspond to, so that 3, 4, 5 triangle, this is our angle theta. And you again can compute that as a degree measure or a radian measure by using your calculator. So we would say 3 plus 4i is equivalent to 5 times the cosine of the arctangent of 4/3 plus I times the sine of the arctangent of 4/3. And there's our complex number, 3 plus 4i in polar form. One more example. Question says write -4 square root of 3 minus 4i in polar form. We look at the geometry again. Here's our complex plane. -4 root 3 is over here, and -4i say is down here. Our angle is from here, polar axis, down into the third quadrant. That angle is theta. Going the other direction, clockwise. Here we would say r is equal to the square root of a squared plus b squared. That tells us r is the square root of quantity negative 4 root 3 squared plus a negative 4 quantity squared like that. And when you simplify, you get 16 times 3 is 48, and 4 squared gives us 16. So 16 plus 48, 16 plus 48 is 64, and the square root of 64 is 8. The modulus of that complex number is 8, and that is our directed distance in polar form. And the arctangent b over a is equal to theta. The arctangent of negative 4 divided by negative 4 root 3, and that simplifies as the arctangent of 1 over square root of 3. In other words, we're looking for the angle whose tangent is root 3 over 3. And according to the unit circle, that would correspond to 7 pi over 6. So the complex number negative 4 root 3 minus 4i has equivalent polar form of 8 times the cosine of 7 pi over 6 plus I times the sine of 7 pi over 6.